Hello and welcome. My name is Chris Parker, and I am the Digital Side Scanning Product Manager for Q's Incorporated. My goal is to work with clients to create effective and efficient pipeline inspection programs that maximize return on investment while embracing new emerging technologies like digital side scanning. Today's presentation is going to talk about rapid pipeline inspection and how digital side scanning can help increase production and quality while reducing overall operations cost on pipeline inspection. With that being said, we're going to jump right into it. We're going to cover several sections today. Section 1 is going to just talk about why a better inspection method is needed, the 4 key problems most customers face, understanding the basics of digital side scanning technology, a case study review of a client who's been running the product for some time now, how digital side scanning can solve those 4 key problems, and then finally, since this is a pre-recorded session, I've tried to address some common, frequently asked questions to hopefully answer everything. But if not, my contact details will be at the end of the presentation, and anyone is more than welcome to reach out for any specifics or additional questions you might have. So why is a better inspection method needed? We all know pan and tilt technology has been around now for 25 plus years, but municipalities and contractors alike are facing a daunting task. Between failing infrastructure and the fact that we have almost 60 million new users that are scheduled to be connected to treatment systems over the next 2 decades, it's impossible to think that utilizing the same technology that was valid, say, 25, 30 years ago is still going to remain valid moving into the future. When you add in some of the common core problems people face is really why we decided that a new technology was needed. Side scanning in particular has actually been around now since 2012. Trenchless industries in general have been slow to adopt other technologies, so that's why we're seeing more of a prevalence now. So hopefully it will gain some interest through this presentation on what it might be able to do for you. So what we find, the 4 key problems most customers face, number 1 would be the personnel issues. There's simply a lack of skilled labor in the trenchless industry. Something we hear often from clients is they either need retraining again and again on their standard CCTV truck, or it's not running simply due to the fact that they don't have personnel to run that truck because they cycle through operators at such a rapid pace. So personnel issues are definitely one of the core problems that most customers face that digital side scanning can help resolve. Number 2 would be operations costs as it relates to both increased labor and maintenance on traditional inspection equipment. It's no secret that pan and tilt cameras have a lot of moving parts and pieces, and in general terms, regardless of manufacturer, the maintenance costs can drastically increase the older the equipment gets. Number 3, accurate historical records. There is simply a lack of historical data available for most clients. In most instances, if I were to ask for, say, 1 or 2 inspection cycles, while that data might be present, it would be very hard to determine the accuracy based on the operator utilizing the pan and tilt camera, or is that historical data spread across multiple servers, multiple DVDs. So accurate historical records is a really important part of this process. And then finally, with accurate historical records, you can make informed decisions. But if you don't have that, you really have the inability to make informed, correct decisions. So that is the 4th issue that we find most customers facing in relation to pipeline inspection. Of course, everybody has their own unique set of problems. The 4 key problems outlined above are by far the most common type, but as it relates to your individual needs, it might vary. But again, this is just a general high-level overview on what most customers do tell us. So simply put, digital side scanning utilizes a high-definition wide-angle camera that produces a 360-degree view of the pipe. It's definitely going to give you unmatched clarity and detail when it's compared to standard pan and tilt style cameras. And of course, all this is going to be accomplished without stopping, which is one of the big key features of digital side scanning technology. So as I mentioned earlier, side scanning, while it is still considered a fairly new technology for the pipeline industry, it has been around since 2012. A lot of customers started to embrace and come online with the technology in 2014. And while it is still considered new, it's definitely a tried and true method at this point, backed up by case studies and peer studies. And oftentimes you'll see side scanning systems being chosen as a leading or innovative technology at most major trade shows. So it is a direction that the industry is heading in. And to be frank, I mean, let's face it, at the end of the day, no one in this conference or no one looking at this presentation is really interested in buying hardware. What you're really looking for is to buy the best data possible. If you could find a way to put a GoPro successfully down a pipeline, you would probably do it, as long as it gave you the quality of view you need, the deliverables, and the information. How you get that visual isn't as important. But what you're really looking for is a system that can give you a robust data package and also be reliable in achieving the collection of that data at the same time. And that's where digital side scanning is really going to shine. The resolution increase allows for a far more defined view, and that increased clarity and detail will give you the most comprehensive view of pipelines possible. The full 360-degree capture means no detail is missed, and it does not rely on an operator to manually pan and tilt to discover or notate defects. And then finally, there's zero moving parts on the camera, which means there's going to be a significant decrease in maintenance and upkeep, since there are no pan and tilt motors, no belts, no clutches, reducing your overall operations cost. And then finally, digital side scanning will give you 3 unique views of the pipe, so that you can go through and do your post-collection assessment at a rapid pace. So digital side scanning in 4 steps. Step 1 for the operator is going to remain pretty much the same as with pan and tilt technology. They're going to set up their camera and transporter just as they would for the appropriate size pipe to maintain center when possible. Step 2 is really where it's going to start to change for them, is that they're going to complete an entire pipe run without stopping. They'll maintain a stable, steady speed throughout. And really what you want to do is look for a system that has a cruise control feature that you can establish a baseline speed and keep that same speed throughout the pipe run without having to manually drive the unit, so to speak. Finally, after completion, the operator is now going to add their operations and observations into the inspection, which normally takes less than about 5 minutes per section. Step 4, now that the inspection is complete, we're going to save that data for future use, and you're going to look for a software program that allows for Esri integration and other types of comprehensive views of your collection system data to help you make those informed decisions. In terms of just understanding what digital side scanning is all about, as you've seen on a few of the previous slides now, you see these flat images, which are at the top of the slide you're viewing now. These are arguably the most important feature in any side scanning system because of what it allows you to do with your collected data. In this example, if you can imagine taking a pair of scissors to the bottom of the pipe, folding it out flat, and that's essentially how flats are created. So take a pair of scissors at the bottom of the pipe, fold it out like a piece of paper, and it's giving you an unobstructed view of the entire pipe. The operator has the ability to quickly identify defects and standard recurring observations like lateral connections. Once you have an understanding of what you're looking for in the flat, it becomes very clear in terms of observation entry, and that's why you can rapidly go through hundreds and hundreds of feet of pipe a day in terms of data collection. It's worth noting too that in this particular instance, we're splitting the pipe at the 6 o'clock position, but some systems out there do give the operator the ability to split at multiple positions. So you could split it at the 12 o'clock or the 3 or the 9. Again, just operator preference when it comes to that. So the idea of reviewing pipes in a flat format is really tough to grasp at first glance. It's definitely a drastic departure from using a traditional camera, having to stop at every joint, having to stop at every lateral. Essentially, side scanning is the complete opposite of what we're all used to doing. You have a strong viewing angle on digital side scanning, which allows for you to do these inspections without stopping. And it's important to notate that the accuracy is actually going to increase again because you're not having to pan and tilt and potentially miss a certain section of pipe. Flat images allow for a quicker review, more accurate review, detection of the smallest defects, and never missing another detail during a pipe inspection again. Outside of the actual flat image itself, I would argue that the software, the side scanning system rather, is only going to be as good as the software that are generating these flat images. Otherwise, you have a very fancy camera that can't do much with your data. So while it's important to understand the hardware details, it's just as important to look at the software powers in the system and what they can do for you. When we start looking at the three views and what the software can generate, you're going to see three unique views. The first is the multi-flat view, which showcases multiple sections of the pipe for quick scrolling and review. The second is going to be the standard flat, which allows for closer inspection, the detailed assessment, and all of your coding and observation work. And then the final is going to be the video playback, which is going to play back like a traditional video, even though it's actually playing back thousands of picture frames that are stitched together. It's still going to play back like a standard MP4 style file. So continuing to understand the technology, the software should have multiple built-in tools. One would be called the Multiselect Tool. This is where you're able to rapidly add observations and reoccurring observations in any particular pipe segment, such as lateral inspections. So in this example, the operator is simply selecting every lateral inspection on this pipe section and notating that it is a live lateral connection. So this is one of the features that are going to save a lot of time for you, and that you can simply go through, mark all these laterals in a matter of really 30 seconds versus having to spend minutes per lateral. You still have all your pan, tilt, zoom features built right in. So if the operator did need to manipulate the view, take individual images or anything else for that matter, they would still be able to do that while they were using the Multiselect tool. But again, it gives you a rapid way to go through and mark reoccurring style observations. So some additional tools to consider are the clock position indicator and the distance position indicators that help you identify what you're looking at on the flat images, because we do understand that, again, it is a drastic departure from simply watching a sewer video. So what we wanted to make sure we did was supply a ton of additional tools to just help your view. So on the left-hand side, of course, you're going to have your clock and distance position indicators. You have a measurement tool, so if you aren't sure about the size of that lateral connection, if you want to measure a crack, you would be able to do that quickly by utilizing the measurement tool. Additionally, you're going to have all your virtual pan, tilt, zoom controls built in, as well as your 360 joint scan, which you simply put your mouse on there, scroll through, and it will give you a rapid look at that joint full 360 degrees. There are many other tools that are built in, but those are the essential ones to complete rapid and high quality assessments. So in this case, it's a full digital side scanning review as if we just started this pipe section. It's a 10-inch PVC pipe. It was 380 feet in length. Of course, PVC is not very eventful for the most part. So in this case, outside of 4 laterals to code, and there were a few areas that there was some staining that could be documented as potential infiltration. That was really all there was to code in this particular line segment. But as you can see there, in a matter of a few seconds, we coded all 4 laterals. We can give it the code, and of course, this is NASCO compliant as well. If you did want to use NASCO coding versus a standard coding system out of the box with any inspection software. But all in all, 380 feet, 2 minutes to code, that's really hard to beat, even with the best operator using pan and tilt technology. So in terms of the overall package of the digital side scanning inspection software, really what you want to look for is a software that has unmatched ease of use. You definitely don't want to look for something that's complicated or complex. One-click observation coding, that is key to the production gains that you're going to get. And very important is no software or camera calibration required. There are a varying degree of digital side scanning systems on the market, some of which have very complicated camera and software calibration procedures that happen to happen daily or weekly or some interval in between. There are other systems on the market that require no camera calibration whatsoever and is out of the box ready by simply selecting the pipe size that you're going to run in the software. So you definitely want to consider that. Of course, you want to look for a software that has highly detailed and custom reporting, NASCO certified, and then really it's an important thing with making sure your data is properly managed and you can utilize it in a visual way. So having an available full bi-directional Esri integration is something that should also be considered when you're looking at software. And then in terms of technical support, you really want to look for an in-house United States-based technical team just to be able to provide you rapid support. And you want to look for a company that has unmatched partnerships with the likes of, again, Esri, CityWorks, Maximo, because, again, we're trying to formulate a more efficient and effective entire package here. So while the digital side scanning is the hardware component, it's very important on the software component that we're managing the data appropriately. So we're going to briefly touch on a case study. In this case, it was City of Tampa, their wastewater department. They are maintaining and inspecting over 1,800 miles of gravity sewer. And to stay on top of their inspection requirements, the city elected to utilize the Q's duct system, which is a digital side scanning system. This was back in 2016, and the city has been able to average a 2.2x increase in footage per day with that system they purchased compared to their traditional inspection trucks. So for them, they've seen a drastic increase in production. And what you can see here is that production increase has been sustained. It wasn't a one-off, one-month type of thing. And it is worth mentioning, too, that these results are being achieved running one less day per week than their traditional trucks, because what City of Tampa has elected to do is Monday through Thursday, they are basically collecting data in the field and using Friday as their coding day. So they're able to achieve that 2.2x increase while still parking the truck for an entire business day. So had they remained in service for all 5 days, they would have probably been closer to a 3 or 3.2x increase in production with the digital side scanning system versus traditional trucks. So it's a very reliable product in terms of gaining production, sustainable. And so in their case, they keep very detailed records on expenses, definitely at the top echelon of clients in terms of, what they're keeping handy in terms of operations costs. So we were able to do a very comprehensive analysis for them. And so what we found was the duct truck, or digital side scanning truck rather, versus the traditional truck, they were able to reduce their operations costs by 55%. Of course, that was coming from the increase in production, and the decrease is the fact that, again, digital side scanning systems have no moving parts or pieces, so they were saving money there as well. In their case, for every 100,000 feet inspected with the digital side scanning truck versus a traditional truck, it was averaging around $26,000 in operational cost savings for them. So a significant amount of money saved running the duct truck or digital side scanning truck versus traditional methods. If you look at it another way in just terms of time savings, digital side scanning is going to allow, again, for rapid pipeline inspection up to 4x traditional inspection methods. We all know that there are going to be different scenarios for pipes and cleanliness and everything that goes into cleaning, or rather TV in a pipe. So we don't make any footage promises. We're not going to sit here and say digital side scanning is going to guarantee you 5,000 feet a day. That's really irresponsible to put it that way. All we're stating is that digital side scanning will increase your production. How much it will increase your production is up to the variables in your unique system. But what we find is most customers easily sustain a 2x increase. And this chart kind of highlights why that is. So in this case, it was same pipe, same transporter, same defects, and even the same operator. The only variable to change was going from a traditional camera to that of a digital side scanning camera. And you can see the time in the pipe was drastically different. as well as time to code that pipe. And then the total time investment is a huge difference. We're going from 50 minutes, almost a full hour, to basically a quarter hour. So, in this case, it's a no-brainer to kind of look at and develop a digital side scanning program for your pipeline inspection. So to kind of address those 4 key problems we discussed at the beginning, so how does digital side scanning solve personnel issues? Well, again, it allows for rapid data collection in the field. There's years of case study to indicate a 2x increase in production with no change of additional labor required. In theory, it's basically like adding a second inspection unit without any additional labor, maintenance, or vehicle assets. And it requires no additional labor for observation entry, and a full, complete inspection can be completed in half the time of traditional methods. So a final consideration in regards to personnel is digital side scanning is extremely easy to operate since no coding or stopping in the pipe is required. So training staff to run it in the field is far more simpler than utilizing pan and tilt technology. So you could definitely have a team of individuals that are competent enough to run it versus, say, one particular operator. Moving on to operations costs, we've already touched on these, and just to kind of summarize, you're going to maintain a 2x increase in production over the lifetime of ownership. Some, of course, are maintaining a much higher degree of production. Of course, City of Tampa that was sustaining a $26,000 savings per 100,000 feet inspected. And with it having no moving parts or pieces, your overall maintenance cost on the particular equipment versus pan and tilt, it's going to be significantly less over the course of the entire lifetime of ownership. And when you consider there's no additional labor requirements and the decrease of maintenance costs and the quality of data collected, you are going to be able to make those more informed decisions, allowing for more appropriate spending on pipeline repairs. So in terms of accurate historical records, you're going to have a full 360-degree survey of every pipe inspected. It's going to give you a comprehensive view that you've never before seen of the pipe. And then it's going to offer you that virtual panning and tilting and zooming capabilities for the lifetime that you keep that inspection file. So there's no question about the accuracy of the record because you, again, have that 360-degree survey. It's an uncompromised view, and you can make accurate comparisons for past or future inspections once you have a baseline on your digital side scanning data. Of course, digital side scanning is going to bring it all together when it comes to making informed decisions. That 360-degree view with that virtual pan, tilt, zoom control, it'll give the end reviewer or the engineering team an unmatched view of the pipe that offers quality that's far above traditional inspection systems. And it reduces observation entries because they would otherwise be outright missed utilizing traditional methods. So it's going to let you know that you have a true complete survey to allow for best decisions. So I'm going to cover some standard questions that we typically get when it comes to digital side scanning. So the first being, what happens when you go underwater? Given that the digital side scanning camera does not move or manipulate, and you have that straight line facing camera, it's going to definitely depend on each individual manufacturer. Certain systems have been designed with a more rounded lens cover to aid with water and debris kind of sliding off the front versus becoming stuck to a flat surface. If there is not significant debris or grease in the water, your camera should remain unaffected. In this instance, you can see the picture there. We're actually over 50% submerged. And then when you come out on the other side of that image, you can definitely have a clear view of the pipe. You can kind of identify the sag there in the middle of the screen. So can you see into lateral connections? This is probably the most common question that we get, and the answer is it varies. Digital side scanning systems are largely developed to be very high production mainline only inspection systems. They are not lateral inspection systems. So if you're inspecting against the flow, a clear view into the lateral connection can be seen as shown on the left there. If inspecting with the flow, in general, about 50% of the connection can be seen, typically enough to determine whether the line is live or capped. But again, it's worth noting that all digital side scanning systems are geared to be a mainline production device, not a lateral inspection tool. Does the pipe have to be clean? It's always the recommendation from any camera manufacturer to clean the pipe for optimal viewing and optimal transporter performance to get through the pipe. Certain manufacturer systems will be more successful than others in unclean lines when it comes to debris due to available voltage to the motors for increased torque to get through that significant debris. So at the end of it, it really is going to vary by manufacturer. In certain manufacturers' case, it can definitely be, partly dirty to heavily dirty, and you'd still be okay in a successful inspection. But again, the recommendation is always to clean pipes ahead of time. Is camera calibration required? As with all systems, again, it's going to vary by manufacturer. You definitely want to look at a system that is zero camera calibration. Multi-camera systems, for instance, generally require a significant calibration if they have a front and rear viewing camera. There's a calibration procedure that's required in order for those images to be appropriately stitched. Incorrect calibration or skipping the calibration could result in missed defects or inaccurate inspection data because of those stitched images being overlapped and potentially missing something. What pipe size range can be inspected with digital side scanning? Again, varies by manufacturer. Most systems on the market have a range of 6-inch to 60-inch pipe. However, some will require you to run multiple transporter platforms versus a single transporter platform that can do that entire size range. So it's important to evaluate what system would be best for the core size pipe that you have in your particular area. What speed can you inspect at? Speed is typically dictated by pipe size for digital side scanning. Generally speaking, in an 8-inch pipe, you're going to be inspecting around 35 to 40 feet per minute, with speeds increasing as the diameter of the pipe increases. Can I still pan, tilt, and zoom though? Of course. It's just instead of being on a manual controller, you're now going to use your mouse to virtually pan, tilt, and move. This pan, tilt, and zoom is available live while you're doing the inspection or after. So that's one of the unique features, is that you don't have to do that panning and tilting and zooming during the inspection. Again, it's available live while you're doing it, but also remains intact after the inspection is complete. Does it require a dedicated transporter system? Yes, some systems on the market are designed to be solely digital side scanning systems with no additional compatibility. Other manufacturers have designed their systems for maximum flexibility with existing equipment and do not require a dedicated transporter. So how can you identify a sag? When you look at the flat images and the way that it splits the pipe at the 6 o'clock position, what you can see is what almost looks like a pipe size reduction, but really what you're seeing is the flow level increase. So if you look at the images to the left of the screen, you see a section of pipe there that almost looks like it's tearing down in size. But again, what you're seeing is the flow level increase, and utilizing the inspection software, you can quickly document that entire sag at both the starting and ending points, automatically being entered into the inspection software. Do you need a dedicated data person? This is a question we get quite often. When digital side scanning first came out, there was a belief that you had to flow the data back into the office before it could be coded, before the observations could be entered, and that's definitely not the case. The main operator on that truck continued their job as normal. It would just be a better usage of time. So rather than spending 8 hours in the field per day, they might spend 6 hours in the field. But again, given that you're going to be getting double the production, you're still achieving high-level results. So even if they did cut back their field time by 2 hours, they're still going to outpace what they were able to do in that 8-hour day. So it's still a win-win. The most production gain that you're going to get, of course, is having the guy in the truck, or having the operator in the truck rather, do all they can from a production standpoint and flow the data back into the office, because now you're keeping that asset on the road as much as possible to collect data. But at the end of the day, not at all. You do not require a dedicated data person. Nothing changes except for the style of data that's being collected. So a quick summary on digital side scanning, since we've talked quite a bit. It offers an excellent return on investment. It's a 4x to 8x increase in resolution over pan and tilt systems. It's a comprehensive pipeline inspection that is unmatched. There's 0 moving parts and pieces, so it equals limited maintenance. And then it's pretty much a guaranteed 2x increase in production, with many clients finding much higher increases than that. And with that said, I'll keep my contact information up on the screen. Again, my name is Chris Parker, the Digital Side Scanning Product Manager for Q's. I can be reached by my cell phone, which is in the bottom left-hand corner, or through email. I'm happy to help answer any questions from just a generic level on digital side scanning or any product-specific questions. Happy to answer those as well. And you can also connect with me through LinkedIn, which is on the bottom right-hand side of your screen there. So I sincerely appreciate everyone viewing the presentation. I hope that it provided some different level of information and education on what digital side scanning is all about and how it can help your entity maybe move forward with a more rapid pipeline inspection. So again, thank you and have a wonderful afternoon.